All right, buckle up, everybody, because today we're going deep on something most people have never even heard of. But it's quietly changing how the whole internet works.
I know, right?
Coherent pluggable optics.
Yeah.
We got this awesome paper by João Pedro, Networking Benefits of Coherent Pluggable Optics, kind of a roadmap for this deep dive.
Perfect.
So by the end of this, you'll be able to not only impress your friends at parties, but actually get why this tech matters.
Yeah.
Like how it might shape the future of, well, everything online. From these giant undersea cables to get this, maybe even your home network.
It really is one of those things, like it's kind of hidden away inside the hardware, but
Yeah.
the impact is huge.
Totally. Okay, so first things first. What are these things?
Yeah.
Coherent pluggable optics.
Yeah, it sounds pretty complex.
Yeah.
But let's break it down a bit. So coherent, that part, it refers to a specific type of optical transmission. And it's all about basically how do we use some really advanced techniques to pack more data onto, those light waves that travel through fiber optic cables. So think of it like sending data in high definition, right? So we can squeeze way more information through the same physical cable.
Gotcha. So it's all about efficiency.
Yeah.
Okay. But what about the pluggable part?
Right.
What makes that so special?
Well, that's where I think the real revolution kind of kicks in. See, in the past, all this optical equipment, it was massive.
Oh, yeah.
You had to, permanently install it.
Yeah.
But these pluggable optics, they're modular.
Okay.
Almost like like a high-tech Lego brick.
Oh, okay.
Right.
Yeah.
So imagine if you could, easily upgrade your internet speed just by swapping out this little module.
So, instead of, rewiring your whole house, you just pop in a new module.
Yeah.
That's game-changing in terms of, cost and just, the flexibility.
Absolutely.
I bet that shift from, the old way to this new way has really impacted how networks are designed.
Hugely. Yeah. And you know where it all really started?
Where?
Data centers.
Okay.
Think about the Googles and the Amazons of the world, right?
Yeah.
Massive server farms.
Right.
They need to move colossal amounts of data between these centers. And that's where coherent pluggable optics really kind of first took off.
Interesting.
They needed something fast, adaptable, cost-effective.
Yeah.
And this technology, it just fit the bill perfectly.
It's wild how a solution for these giant data centers is now rippling out to the whole internet.
Totally. And what's even more interesting is that we're starting to see these pluggable optics move beyond the data center. And
Okay.
they're going into, metropolitan and regional networks.
Uh-huh.
We're even starting to see them in long-haul connections.
Whoa. So from connecting servers across a city to potentially spanning continents.
Yeah.
That's crazy. But I imagine there are challenges, right, when you try to push this technology to handle those more demanding applications.
Oh, for sure. Longer distances, higher speeds. I mean, that requires more powerful optics.
Yeah.
But then you still need to fit all that power into, a small pluggable form factor.
Right.
So it's this constant push to pack more performance into smaller and smaller packages.
Like squeezing a rocket engine into a matchbox.
Yeah.
You need the power, but it has to fit.
Exactly. It's a delicate balancing act, but the progress we've seen it's remarkable. I mean, we're constantly seeing new innovations that are really, really pushing the boundaries of what's possible.
Okay. So we've talked about these powerful little pluggable modules, but the paper also highlights some really interesting ways to actually use this tech. What are some of the things that really jumped out at you?
Well, one of the things that I think is really transformative is this whole rise of what we call point-to-multipoint connections,
Okay.
or P2MP as it's often called.
P2MP. Okay, that sounds a little like something out of a technical manual. Can you break that down for us a bit?
Yeah, so it's a little bit of a shift in thinking. So traditionally, you would need a dedicated connection for each point in a network.
Okay.
Right. But with P2MP, you can actually have one powerful optic that can essentially split its capacity to connect to multiple devices
Oh, okay.
simultaneously.
Yeah.
So it's kind of like, imagine a main highway that branches out into smaller roads, right?
Okay.
So it's efficiently directing traffic where it needs to go.
So instead of separate lines for every connection, you've got one super optic that can handle multiple connections at once.
Exactly, yeah.
That sounds incredibly efficient. What's the magic behind that? How does that actually work?
Well, the technology behind that is called digital subcarrier multiplexing,
Okay. Yeah.
or DSCM for short. And you can kind of think of it like, you know, how you have multiple radio stations, right?
Mm.
All broadcasting on different frequencies,
Right.
but they're all using the same transmission tower.
Right.
So in a similar way, DSCM allows us to pack multiple independent data streams onto a single optical signal.
Oh, so you're basically getting more bang for your buck
Exactly.
with each fiber optic cable. And the paper mentions some pretty impressive cost savings here.
Yeah, absolutely. I mean, some studies have shown that using P2MP can potentially reduce capital expenditures by, 25 to 37%
Wow.
in metropolitan networks
That's huge.
compared to, those traditional point-to-point setups.
Okay.
And it's not just about saving money up front. There are also some really significant long-term benefits as well.
Okay, this is where it gets really interesting, I think, for me. Let's talk about those long-term benefits. Like, what kind of impact are we really talking about here?
Well, for one, P2MP allows you to significantly reduce the number of optical amplifiers that are needed in a network.
I got to admit, I don't know much about optical amplifiers. What do those even do?
So basically, they're like booster stations
Okay.
along the fiber optic cable.
Yeah.
And their job is to keep that light signal strong, over long distances. But these amplifiers, they're expensive to install, and they consume a lot of energy.
Oh, okay.
So by reducing the number of amplifiers needed, P2MP makes networks not only more cost effective, but also, more energy efficient,
Right.
more environmentally friendly.
So less equipment means, lower energy consumption, smaller carbon footprint.
Exactly.
That's a win for everybody.
Yeah.
That's amazing. It's really wild to think that like such a fundamental change in how you set up a network can have such a ripple effect.
Absolutely, yeah. And the applications go even further than that. The paper delves into some really fascinating possibilities. For example, in certain scenarios, P2MP could even allow us to bypass routers altogether.
Wait, bypass routers.
Yeah.
Isn't that like a pretty crucial part of how the internet works?
Right. And it's not about eliminating routers entirely,
Right.
but it's more about optimizing data flow.
Gotcha.
So remember how P2MP allows multiple devices to connect to a central hub.
Yeah.
Well, sometimes those devices might need to communicate directly with each other.
Right.
Right. And with DSCM, we can actually create those direct connections without having to send data through the central hub, through the router.
So it's like creating like express lanes within the network.
Yeah, exactly.
Allowing data to just take a more direct route.
Exactly.
Okay, that has got to have a huge impact on speed and just overall efficiency.
Yeah, absolutely. By reducing the number of hops that the data has to make, we can, lower latency, we can improve the overall performance of the network. And then there's another really fascinating application I think you'll find intriguing. DSCM can also be used to achieve bidirectional transmission on a single fiber.
Okay, break that down for me.
Yeah, sure.
Bidirectional transmission.
Yeah.
So does that mean like sending data in both directions at the same time?
Exactly.
Using just one fiber optic cable?
That's exactly it.
Oh, wow.
And this is a big deal, especially when it comes to, connecting homes and businesses with existing fiber infrastructure.
Okay.
Traditionally, you would need two separate fibers.
Right.
One for sending data, downstream to the user.
Yeah.
And then another one for sending data upstream, back to the network.
So with DSCM, you're cutting the infrastructure requirements in half.
Exactly, yeah.
That seems like a total game changer for expanding internet access and potentially making those like high-speed connections more affordable for everybody.
It is. And it opens up some really exciting possibilities for using P2MP to enhance, existing networks like PON. Yeah, passive optical networks. And PON is already, widely used for fiber to the home connections, but it has limitations in terms of, speed and capacity.
So you're saying like with DSCM, we could kind of like supercharge these PON networks.
Yeah, exactly.
Give them the power to handle way more data.
Yeah.
At higher speeds.
Exactly. Yeah. We're potentially talking, gigabit speeds and beyond, all delivered over existing infrastructure.
Wow.
And this is where, those cost savings that we talked about earlier become really significant.
Yeah, we've talked a lot about, data centers and large scale networks, but this is where it like starts to hit home.
Exactly.
Like literally.
Yeah, this technology has the potential to really change how we connect to the internet in our everyday lives.
This is pretty mind-blowing stuff. I feel like we've only scratched the surface here.
Yeah, it really is.
Like what other kind of interesting applications of coherent pluggable optics are people like working on exploring?
Well, one area that researchers are getting particularly excited about is the potential to use these optics for more than just data transmission.
Okay.
Like we're talking about actually integrating sensing capabilities directly into the optical modules.
Sensing. What do you mean sensing? Like what kind of sensing?
So imagine being able to like monitor the temperature or the vibration or even the strain along a fiber optic cable like in real time.
Mm-hmm.
So this could be like absolutely revolutionary for applications like infrastructure monitoring. Like imagine if you could detect tiny, tiny structural changes in a bridge or a tunnel long before they become a serious problem.
That's incredible. So instead of just sending data, these optics could also act as a network of tiny sensors, right?
Exactly.
Constantly feeding back information about the physical world.
Yeah, I mean, it just opens up like a whole new realm of
It
possibilities.
really does, yeah. Okay, so before we get too carried away, dreaming about the future here, let's kind of take a step back and recap what we've learned.
Yeah.
We started with coherent pluggable optics, these tiny but mighty modules that use these sophisticated light waves to transmit data over fiber optic cables.
Yeah.
Initially designed for data centers, they're now branching out into a wide range of networks, everything from metropolitan areas to those long haul connections.
Yeah, and we explored that fascinating world of P2MP, right? Which uses DSCM to basically allow a single optic to connect to multiple devices all at the same time. And this is a technology that's not only, driving down costs and boosting efficiency, but it's also making networks more sustainable,
Okay.
and it's opening up those new possibilities for applications like fiber to the home.
And we even touched on that potential for these optics to become like smart sensors, right? Gathering information about the world around us.
Yeah.
It's clear that coherent pluggable optics are more than just a behind the scenes technology. They're
Yeah.
they're really shaping the future of how we connect and how we interact with the world around us.
Absolutely. It's a really dynamic and rapidly evolving field. And I think what's so exciting is that we're really just at the beginning of this journey. Who knows what breakthroughs are just around the corner.
I know I'm personally really excited to see what the future holds. This has been a truly incredible deep dive into the world of coherent pluggable optics. So
Yeah.
huge thanks to Juan Pedro's paper for providing such a fascinating kind of roadmap.
My pleasure. It's always a joy to get to explore these cutting edge technologies and just, kind of see how they're pushing the boundaries of what's possible.
And to our listeners, I encourage you to kind of keep an eye on this space. Coherent pluggable optics are a perfect example of how seemingly small technological advancements can really have this ripple effect, transforming the way we live, we work, we connect with each other. So until next time, keep exploring, keep learning, and we'll catch you on our next deep dive.